So are you concerned about quantum computing? Or do you think it's already too early to talk about it? I'm here to answer those questions for you. As a fresher, when you're thinking about it, is it the right time to get started on quantum computing? What can you learn? Where will it take you? I'll just answer those questions for you and demystify quantum computing. I'm Sridhar Sheshadri, founder of Spotfrog Technologies, here to answer these questions for you. Let's get started. So it's never too late or never too early to get started. When it was times of classic computers, I was still a school-going kid and somebody introduced me to those computers. And that's where my love and my journey started. As part of the journey, what I realized, programming is not the only thing. There's problem solving, there's critical thinking, there is imagination. And a lot of that imagination just goes into trash can the moment we just start to only code or think about scoring marks. I'm here to take you further ahead from the conventional journey. So what is quantum? Does it ring any kind of bell for you? Quantum is like a smallest unit. But of what? Matter? A molecule? Atom? So you might have studied about these concepts of time travel, all those fantasies and fiction of science, where everybody believed if there is a clock or a time travel machine, people would want to sit in it and would go back in time. I'm pretty sure humanity would reach that stage someday and science would crack that problem. But what exactly quantum computing is going to do for us is for sure pause the machines, pause the time in computer domain. What does that mean? So typically classical computers were made efficient and intelligent in AI by solving linear differential equations or a linear equation system. And they really become compute extensive when you really have a lot of data or you want to really solve a lot of futuristic problems. In classic computer system, you already know the smallest unit is called bit. And this is typically a binary system made of zeros and ones. But in quantum system, the smallest unit is called qubit, Q-U-B-I-T, qubit. Qubits have a very different nature. And how it really typically works is there are possible ways, there are spins. It can zig, it can zag, it can zig and zag both. What does this mean? This means there are multiple possible states a qubit can have in its spin nature. If you think of atoms, how these atoms spin, how they behave, that you might have studied in your elementary science. So a lot of knowledge comes from that kind of basics. If it doesn't interest you, don't be scared of this whole paradigm. This is evolving. There is lots to do in this paradigm. The more you understand, the more you explore this in future, there's needs of policy making. There are needs of thinking of use cases. How would this be implemented? I'll talk about a couple of few use cases that can be implemented in this domain of quantum computing. So quantum computing can be used much more efficiently, say if you want to predict weather in next 5 minutes. So what's the weather is going to look like in next 5 minutes? That's going to be much accurate, much meaningful as compared to what AI is doing as of today. The moment you're able to predict the state of the quantum unit or an atom, the whole mechanics is very much paused in time domain. So what I'm trying to talk about, the systems become very efficient, the compute power required goes substantially low compared to classic computers, because you have multiple variations beyond just the binary system. And the way the existing hybrid cloud paradigms are being designed by big corporations is enabling classical computer systems to interact with these quantum computers, which are kept somewhere in an isolated location, or using microwaves to achieve very similar behavior of atom and get you the fastest compute that's really desired. So what can we do with this? There are multiple use cases where you want to probabilistically know what will happen in future that can be calculated with much higher accuracy. So I'll take a very simple example. if I have 3 cricket balls that I'm playing with and I throw them in a certain direction, using AI, if I ask you, can you predict the direction the 100th time when I'm going to throw these balls? Using the historic data, you can predict the possible directions where the ball will go in next 10 minutes, next 5 minutes, probably even in nanoseconds. Imagine now there is a small bottle of glitter and you have so many smaller particles. If I throw all of them in the space right away and I use the same algorithm to predict the path of each glitter particle, that's where the non-linear quadratic equations would come into play and classic computers would really fail, or it will become compute extensive for them to predict for it. And that's the exact scenario where you can use quantum machines and quantum computers to predict things very accurately. This is just the beginning of the era of quantum computing for people like you and me. There has been research that has gone into this domain for a while now, but this will become a commodity pretty soon. If quantum physics, quantum chemistry, quantum mechanics has always got your attention, I would say don't miss this opportunity. The train has arrived. You should just get started and see the possible opportunities to take any kind of role that any quantum computing team can provide you. It will not happen today where you will seek the roles, but in your next 4 or 5 years of journey while you are just getting started in your career, if you parallelly explore this, you learn more about it, that would be the perfect timing where this market would open up. People with that knowledge will be given first preference for solving for real world problems by enterprises and service integrators. There's big opportunity ahead of you. Good luck, get started. Thank you.